Welcome back to the lecture of transforms and partial differential equations MA3321. This is Dr. V. Vijayalakshmi, Associate Professor, Department of Mathematics, SRMVEC Engineering College. So next we'll continue the Unit 1 continuation, partial differential equations. Today we are going to see about the Lagrange's linear partial differential equation. There are two methods in Lagrange's linear partial differential equation. One is method of grouping and method of multipliers. In this video, we are going to see about the method of grouping. The grouping, the Lagrange's linear equation is of the form capital P small p plus capital Q small q equal to R. This is the form, this is the equation of the form PP plus QQ equal to R. This is the format, this is the form of the Lagrange's linear partial differential equation. Here P, Q and R represents the functions of x, y, z, and small p and small q are the variables dou z by dou x and dou z by dou y and so on. So here the first step of solving this Lagrange's equation is the subsidiary equations. For both the methods, we have to write down the subsidiary equations, which is nothing but dx by p dx by p equal to dy by q is equal to dz by r. So this is of the equation of the form pp plus qq equal to r. Here where pq and r are functions of x, y, z is known as Lagrange's linear equation. To solve this type of equation, we have to consider the equations alpha equal to a and u equal to alpha and b equal to b. Then a and b are arbitrary constants of x, y, z and arbitrary functions of x, y, z. A and b are arbitrary constants, whereas u and v are functions of x, y, z. So consider du equal to dou u by dou x into dx plus dou u by dou y into dy. This is a working procedure. Plus a dou u by dou z into dz. So comparing 1 and 2, we have dou u by dou x is equal to t, dou u by dou y into dy plus dou u by dou z into dz equals to 0. So after solving these differential equations, we'll get the subsidiary equation is of the form dx by p equal to dy by q equal to dz by r. So how to solve the equation of the method of grouping problems? So find the general solution of px plus qy equal to z. So here this is of the form pp plus qq equal to r format. In that the subsidiary equations are dx by p equal to dy by q equal to dz by r. So here p is x, dx by p is x, q is y and dz by z. That is dx by x equal to dy by y equal to dz by z. So take the first two ratios. Ratios means here represents dx by x is first ratio, dy by y is second ratio and dz by z is third ratio. So compare any two ratios taking equations 1 and 2. Dx by x is equal to dy by y. So if you integrating this, what happens? Log x is equal to log y plus a log c1, because integration will put the constant integration, therefore log C1. So since it is in the answer is of the form logarithmic, so bring log y to the other side, log x minus log y equal to log C1. So log of x by y equal to log of C1. So if you eliminate log, you will get x by y equal to C1. That is the first solution. Similarly, if you consider the second and third ratios, that is a dy by y is equal to dz by z. Similarly, if you integrate this, what happens? Log y equal to log z plus log c2. Therefore, what happens? Log y equal to log z plus log c2. Bring log z to the other side. Log y minus log z equal to log c2. So log of y by z is equal to c2. So eliminating the log, y by z is the second solution. Y by z is equal to c2. Therefore, the final solution is phi of c1 comma c2 equal to 0. That means phi of x by y comma y by z is equal to 0. It is not necessary that we have to take 1 and 2 and 2 and 3. We can take 2 and 3 also. We can take 1 and 3 also. Depending upon our choice, we can take the solution ratios 1 and 2 or 1 and 3 or 2 and 3, out of which 2 solutions you have to take. So as a final solution, phi of u comma v equal to 0. U will be the first solution and v will be the second solution. Similarly, next example, p tan x plus q tan y equal to tan z. Here pp plus qq equal to r format. This is also coming under method of grouping. The subsidiary equations are dx by p equal to dy by q equal to dz by r. Here p is tan x, q is tan y, r is tan z. So dx by tan x equal to dy by tan y equal to dz by tan z. So taking the first two ratios, dx by tan x equal to dy by tan y. So on integrating, so bring the tan x to the numerator as cot x at dx equal to cot y dy. So integration of cot x is logarithm of sin x. Log sin x is equal to log sin y plus log z, because integration of cot x is what? Cos by sin. Cos by sin means if you write the log of the denominator, that will be equal to the numerator. Therefore, log of the sin x, if you differentiate, you will be getting what? If you differentiate the denominator, sin x, if you differentiate, we are getting numerator as cos x. Therefore, we can write what? Log of the denominator. Therefore, log sin x is equal to log sin y plus log c1. So, bring sin y to the other side. Log sin x minus log sin y equal to log c1. So, log a minus b, log a by b. So, log sin x by sin y equal to c1. Therefore, x by y equal to c1. Similarly, take other two ratios, either 1 and 3 or 2 and 3. Whichever you feel comfortable, you may take. So, there also, if you take 2 and 3, what happens? dy by sin y equal to dz by sin z. So, if you integrate similarly, what happens? Log of sin y equal to log of sin z plus log of c2. Therefore, what happens? Bring that log sin z to the other side. Log sin y minus log sin z. So, you write sin y by sin z equal to log c2. So, eliminating the log will get what? Sin y by sin z equal to c2. Therefore, the final solution is phi of u comma v equal to 0, phi of sin x by sin y comma sin y by sin z equal to 0. Hope you all understood this method of grouping. This is how the method of grouping we have to do. So go through the solutions. Going into the next problem. This is a problem under method of multipliers. So method of multipliers will be coming in the next section, which has a multiplier 1, 1, 1. This is next method, second method of doing, and this is px square plus qy square equal to z square. So this is again a grouping method. Grouping method means there will not be any bracket or something like that. In method of multipliers, we have mx minus nz into p. Like that it will come, method of multipliers. So here simply px square plus qy square equal to z square. This is of the Lagrange's form, pp plus qq equal to r. The subsidiary equations are dx by p equal to dy by q equal to dz by r. So if you integrate dx by x square equal to dy by y square. So bring the dx by x square, how you integrate? Minus 1 by x equal to minus 1 by z plus c1, automatically 1 by c1. So if you manipulate it, what happen? 1 by y minus 1 by x. Okay. So when you take the other two ratios, dy by y square equal to dz by z square. So integrate, bring that y square to the power side, y power minus 2. Integration of y power minus 2 dy equal to integration of z power minus 2 dz. So what happens? Minus 1 by y equal to minus 1 by z plus 1 by c2. So finally solution will be, we eliminate the constant c1 and c2. Phi of 1 by y minus 1 by x, 1 by x minus 1 by y, comma 1 by y minus 1 by z is equal to 0. So this is how we have to do the Lagrange's partial differential equation. Method of grouping type 1. So this is another method, x square minus yz into p plus y square minus zx into q equal to z square minus xy. So here write the partial differential equation, subsidiary equation, dx by x square minus yz, dy by y square minus z square, y square minus 2z, dz by z square minus 2y, like that. So here the method of solving is different, because in that previous problem and all, the method of grouping, we will integrate. If you take any two ratios and integrate, and we will get the solution. But here, so consider the equation ratios 1 and 2. Subtract 1 from 2. So dx minus dy. Similarly, denominator also difference. Find out the difference. Equal to dy minus dz. Similarly, find out the difference. So here d of x minus y by denominator you mark something in the form of x minus y. So write x minus y steps. So then you integrate. What happens? Cancel out the remaining steps. Integration of d of x minus y by x minus y equal to integration of d of x minus z or y minus z by y minus z. So you may take any two ratios, either first and third or second and third. So if you do the integration, you will be getting log of x minus y by z minus x or something like that. This is the first solution. Here, first part is a method of grouping and second part is a method of multipliers. Then only we can get the two solutions. So minimum two solutions we need. So this is a method of grouping. So you may choose multipliers as 1 x y z. So numerator x dx plus y dy by z dz divided by denominator. So denominator, if you expand and simplify, you will be getting, integrating, you will be getting x square by 2 plus y square by 2 plus z square by 2. This is method of grouping. This is my second solution. So phi of first solution comma second solution will give you the answer. So in this problem, there is one solution coming in the method of grouping and the second solution is coming in a method of multipliers. Okay. Thank you. So we'll see the next remaining lectures in the next video. Thank you. The partial differential equation. In this lecture, we have covered the linear Lagrange's linear partial differential equation, method of grouping model. Thank you.